Hey guys, in this video we're going to talk about transforming absolute value functions, and then we'll talk a little bit about some sequences of functions. And so we talk about absolute value functions because they're really easy to graph because the shape is generally the same almost every time, and the transformations are just the same transformations as you would use for any other function. So it happens to work out very nicely. And so let's go ahead and begin. So the first one we have transforming is 3 times the absolute value of x. The absolute value of x is a V shape, if we all kind of know that by now. Let me go ahead and graph that one on here just to show you as a reference, because that's where we always start as a reference. The absolute value of x, this one, f of x, and we talked about this in the other video, is centered as a vertex at the origin, and its sides are rays with a slope of 1 and a slope of -1. And it looks just like that. So it's this V shape every time. Well, if you multiply that function by 3, all of your y values are going to be tripled. And so what that means is your y values now are all going to be 3 times more than what they were. And it started at the origin. Now, the vertex doesn't move because nothing was done inside the absolute value bars, and there's nothing behind it, plus or minus. So the vertex is still at the origin, and you're just going to basically take all of the values for y, and you're going to multiply them by 3. So instead of up 1 over 1, it's going to be up 3 over 1. And essentially, for absolute value functions, that number in front is going to behave like a slope. And so all it's going to do is transform your function, and it's going to make it narrower. Just like that. And just like that. So the black one is the one we want, and that's basically what I'm going to be doing every time. I'm not going to graph both of them. I'll just graph the one that is in question. All right, here's our second one. This one is absolute value of x with a negative in front, then plus 2. So what happens now is we have to move the vertex because you have a plus 2 at the end. The negative in front here doesn't have anything to do with moving it around. It just either makes it narrower, wider, or it flips it. So the plus 2 means the vertex used to be here, and now it's going to be moved 2 units up. The negative in front is going to, instead of going up 1 over 1, it's now going to go down 1 over 1, and all of your y values are going to be the opposite sign now. So what happens is it flips it, and this is what your function is going to look like now. And I'm going to do this kind of fast so you can always rewind, because it's basically the same shape every time. So there's nothing really to it. That's why absolute value functions are used. They're not really used that much in real life, some places, but they're really good for showing transformations. And so there's our function. Okay, this one. First thing we've got is we have this -3 with the x in the parentheses. So that tells us that we need to translate it to x minus 3 units. And that's going to go, since it's a minus, you can go to the right 3 units. So right 3. And so the vertex used to be here, and now it's going to be here. You have a positive 2 in front, so that's going to double all your y values. So instead of going up 1 over 1, you're now going to go up 2 over 1. And it's going to make the slope of your sides 2 now. That's a really easy way to understand these transformations with absolute value, and later on quadratics, because that's basically how it's going to work every time. So I really try not to overcomplicate things when we talk about transformations. And so there's that one. Okay, this one, we have a vertex now that used to be at the origin. The -1 here is going to move it 1 unit to the right, okay? And then the plus 3 is going to move it 3 units up. So 1 to the right, 1, 2, 3 up, and there's our new vertex. You have a minus in front, which means it's now going to go down 1 over 1 for our sides. And it's super important to get that vertex where it's supposed to be, because that's where a lot of people mess up, especially the left, right. And all of you have your graphic organizer. This year it's blue. It shows you how to translate these and what they mean. So you should be looking at that every time if you don't know. Okay, and there is your new absolute value function. Okay, this one, we've got now a +1 with the X and the absolute value bars, which are grouping symbols, so they behave like parentheses, but they're also absolute value. So the +1 means it's going to move it back 1, and I know that's opposite, but that's how it works. The -3 at the end says down 1, 2, 3, and there's our dot. Again, that 2 right there has nothing to do with the vertex. It's the sides. So we want left 1, down 3. So I'll even write that up here. Left 1, and then this one was down 3. All right. The 2 says now I need to go up 2 over 1. So my slope of my sides are 2's now. And this one, I guess, would be -2. But it's still up 2 over 1 in both directions. And we connect our points. If you're ever curious if you got this right or not, you can always plug in some numbers to see if they worked. And I think we could actually do that on this one to show. Most people don't do that, but you certainly can. So what I'm saying is, let's say this was a test question and you didn't know if you did it right. Well, we know that we have the point, let's see this one. This point right there is 2, 3. So we know that 2, 3 is on the graph of the function. So if you plug in 2 for x, okay, so 2 + 1 - 3, the result should be 3. Well, let's see if it is. 2 times 2 + 1 is 3, -3 at the end. 2 times 3 is 6, because the absolute value of 3 is 3. And we get our correct y value back. And you can always do that. You can always spot check a couple of points just to make sure you did it right. Okay, our last one here, where we're just translating this one. They don't really get that hard. This one is going to be x -2, so we're going to go 2 units to the right, and you're going to want to go to the left, but you can't. You got to go to the right. -2, 2 to the right. The +4 goes 4 up. 1, 2, 3, 4. And there's our dot. -3 says now we go down 3 over 1, down 3 over 1 in both directions. Ooh, that's not good. Wrong one. Pay attention. Me. All right. It happens though. It's okay. Okay, so there's that side, and there's this side, and we are finished. So that one is done. So let's look at a couple other ones here. This one, we want to take our absolute value of x and we want to translate it first 3 units to the left. So if we translate it 3 units to the left, our parent function, absolute value of x, it would be, there's our dot, and then you would just go up 1 over 1. All right. Draw your sides. Same over here. Because in words, that's all that means, right? So we have to be able to interpret words in mathematics and written communication. Okay, so there's our function. Now we have a picture of it, and we want to now write that function. So the function that will correspond to this, we moved, and actually I did that wrong, didn't I? I went 2 units over and 1 unit up. Why did I do that? Let me do this again. Do it like this. I'm talking and I should be paying attention. 3 units to the left. Down there. Get rid of this. Up here. And I'm not gonna delete this video and make it again. I'm gonna show you what happens when I make a mistake, because everybody does. But I caught it. It just doesn't look that good, but that happens. So Now it's translated 3 units to the left. Okay, so our function is now f of x equals 3 units to the left. If you look at your graphic organizer, you're going to add to the x inside the parentheses, which are the absolute value bars. So x plus 3 is going to move it 3 units to the left. The domain of this function goes from arrow to arrow, so it's all real numbers. And the range starts at 0 for y and goes up, so all y greater than or equal to 0. All right, next one. This one, we are translating 2 units to the right for this. And now I'm going to kind of get a different marker here. Okay, so I'm going to start here at the origin. I'm going to move it 2 units to the right. So 1, 2, okay. And now I'm going to reflect it across the y-axis. If I do that, it's going to go all the way over here. So it's going to go all the way over here to this point, and that is going to be my new vertex. So I'm reflecting it across the y-axis, and so it's still going to be going up. So let's get our marker, up 1 over 1, just like this. And I'm going to do this one right this time. All right. So let's take a look. So looks like that's where our function is going to be. All right, now let's write the function down. The function is going to be, if you just look at the graph now, the graph is going to be f of x is equal to, and it looks like it wound up 2 units over to the left, which would be x plus 2, right? So that's what it looks like from the graph. Now, what if you didn't have the graph to look at and all you had were these words? Well, if you look on your graphic organizer, the first thing, translate 2 units to the right, like this, you're supposed to do f of x is equal to x minus 2, right? Because if you translate to the right, it says to subtract from x inside the parentheses or the absolute value bars. Then it says to reflect it across the y-axis. So now, the second move would be to take the x and replace it with negative x minus 2. Now this, if you graphed it, would be the same exact function as this one. If you took technology and graphed both of those in the same coordinate plane, and you look at them and you think, why? They don't look at all similar. But you realize this is absolute value, and you are completely allowed to take a negative 1 out of both of these terms and make it negative 1 times x plus 2 if you factor that negative 1 out. Well, the absolute value of negative 1 just is 1. It just goes away. So what happens is this negative 1 goes away, and you wind up with x plus 2 in your absolute value bars, which is the same as what you got here from the graph. Now, if you didn't have the graph to look at, then you might have to do this stuff. This is acceptable, that function right there. However, if you're looking at a textbook, they would probably have this one because it's better, it's more simplified. So it's one of those things in math you just have to get used to. People simplifying things, and you got to just figure out how they simplified them so that your answer is actually correct. It's just not as simplified like somebody else's. So the domain is all real numbers again. And then the range would be 0 on up for the y values, all y greater than or equal to 0. All right, now let's look at this one. This one we're going to translate, let's see, 1 unit up. So we used to be at the origin. We're going to go 1 unit up, and then we're going to reflect across the x-axis, this axis. So what we do then is we're going to go all the way down to that point, and that's going to be our new vertex. Now, what happens though is when you take your function and it's going up and you flip it, it's now going to be going down. So when you reflect across the x-axis, it is going to take that function and it's going to flip it down, just like that. Okay, and we connect our points here, make it look good. Okay, so now we have a function. If you just looked at the graph, it would be f of x is equal to, and it would be absolute value of x, and then minus 1 with a negative in front because it's going down. So since it's going down, you have to have that negative in front to change the slope to down 1 over 1, negative 1. So let's see if you would get that following the transformations. So if you take absolute value of x and you translate it 1 unit up, you would add a 1 to the end, right? That's what the thing says, the graphical organizer. If you reflect it across the x-axis, it says to change the signs of all the terms. Well, you have 2 terms here, and you would change it to negative absolute value of x minus 1, and now you get the same thing here that you should have, and you have the same function now. The domain is all real numbers again. And your range is going to be all y now from negative 1 down, all y less than or equal to negative 1. Okay, this one. Now we have to translate it 2 units to the left. So let's take our other marker here. Okay, so we're going to start at the origin. We're going to translate 2 units to the left. 1, 2, and there we are. 1 unit down. Right here, and now we're going to reflect across the y-axis. So now we're going to flip it all the way over here to this one, and that's now our new vertex. Is it still going up or going down? Well, it didn't reflect across the x, so that means it's still going to be going up. And we did not have a widening or narrowing this time, so we're going to not worry about that. We're going to connect our points. That one. And that one. All right, so now let's take a look. F of x is now equal to, we want 2 to the right and down 1. So that's going to be x minus 2. That's 2 to the right. And then down 1 is a minus 1 at the end. Okay, so that's if you look at the graph. If you don't have a graph to look at, then you would start with your absolute value of x, translated 2 units to the left, you'd go x, and then that would be a plus 2, right? 2 units to the left plus 2. 1 unit down would be a minus 1 at the end. Reflect across the y-axis, you take the x and you put a negative x in. Replace each x with negative x. So these two don't look the same. However, our little trick is that we can take a negative 1 out of this, factor a negative 1 out of both terms, and we get x minus 2 minus 1. And then again, the negative 1 is going to go away because it's absolute value, and we wind up with x minus 2 minus 1, which is exactly what we have up here, so we're still in good shape. Domain is all real numbers again. And our range is all y values from negative 1 on up. So y greater than or equal to negative 1. And that is our range. All right. Now we got some fun ones. We have no graph. And whatever we get, we're going to keep. So we're not going to sit there and play with it and change it around. We're going to get our answer and be done with it. Okay, so you're going to start with absolute value of x. Now we're going to change f of x into g of x. So our final answer is going to be g of x instead of f of x. So compressed horizontally by a factor of 3. So what happens there is you need to take the whole thing and you need to put a 3 in front. Like so. That's going to compress it horizontally by a factor of 3. Reflected across the y-axis, you're going to take this inside the absolute value bars and make it negative. Translated left 5 units is you're now going to take the function, and actually here, this negative in front of the x isn't going to do anything. And so that negative in front of the x, you might as well just get rid of it. So this is actually just going to turn into this again. Because if you didn't move the graph left or right and you've reflected across the y-axis like this, right? If you just moved it up or down or made it narrower or wider, like this right here, and you reflect across the y-axis, it's gonna be the same thing. So this and this are identical. Okay, so I can actually do that. Translate left 5 units. And so now that's gonna be x, and that's plus 5. That, left 5 units. And then 3 units up, I just need to put a 3 at the end, plus 3. And that looks pretty good. So g of x, 3, x plus 5, and then plus 3 at the end should be correct for that one. All right. Now, usually on the end of course test, they don't give you a lot of these things in the same problem, but I am, just to kind of toughen you up a little bit. Okay, so for this one, we're going to take absolute value of x. We're going to stretch it horizontally by a factor of 1/3. So that means you need to put a 1/3 in front to stretch it. And what that will do is it will take it and it will make it wider. Reflect it across the x-axis. Okay, so this time to do that, you just have to take the whole thing and put a negative in front, because you take the negative of all the terms. And there's only one term, right? So you just put a negative in front. Translate 4 units to the right. So negative 1/3. And if you're going to the right, you have to subtract. And so that would be minus 4. 1 unit down. Same thing. And then a minus 1 at the end. And then g of x equals. And we're done with that one. Okay, this one. First thing we're going to do is we're going to stretch it horizontally by a factor of 1/2. So we put a 1/2 in front. That'll make it wider. Reflect across the y-axis. Okay, we've already seen this trick. Replace the x's with negative x. But again, this is going to be the same thing as this. So we might as well just revert back to the original one, this one. Translate left 1 unit. So if we're going to go to the left, we have to add x plus 1. And then up 6 units, we're going to put a plus 6 at the end. And a g of x equals. And that should be the correct answer for that one. And the last one, we're going to take our original and compress it horizontally by a factor of 3. So we're going to put a 3 in front. Reflect across the x-axis. That means we put a negative in front of the whole thing. That will flip it down. Translated right 2 units. So negative 3. If you go to the right, you have to subtract 2 units. So minus 2. And then translate down 8 units. X minus 2, minus 8 at the end, and we'll put a g of x in front. Okay, and that should be the answer for that one. So we have transformed, and with sequences of transformations even, absolute value functions. These are going to behave like most of our other functions. So remember to like my video and subscribe to my channel if you haven't already. We'll see you guys later. Bye.